Well, it is 6:30, so we'll get started here. Hello, everyone. Welcome to today's webinar on Minnesota climate conditions, observations, trends, and outlooks. My name is Emma, and I'm the Education and Outreach Coordinator here at the Minnesota State Horticultural Society. It would not be possible for MSHS to offer great classes like tonight's program without the generous support of donors and members. If you enjoy tonight's program, please consider gifting a small donation by visiting our website at northerngardener.org/support. If you're not a member of MSHS, now is a great time to join. Members receive not only our award-winning magazine, but also discounts at nurseries and greenhouses, free tickets to local home shows, free webinars, and more. Now, just a few housekeeping items before we begin. You're attending the webinar today in listen-only mode, so you'll be able to hear our presenter, but we cannot hear you. That way, there won't be background noise. If you have questions for our presenter, you can type those in on the panel on the right side of your screen. Go ahead and ask those questions as they arise. Kenny is happy to answer them at the end of the webinar. If you do not see the panel, look for an orange arrow in the upper right corner of your screen. You can click on that arrow and it will pop out that panel. And now let's welcome tonight's presenter. Dr. Kenny Blumenfeld is a climatologist who loves storms, blizzards, being outside and talking to Minnesotans about their weather. He works for the Minnesota State Climatology Office of the DNR and holds an adjunct faculty position in the Department of Soil, Water, and Climate at the University of Minnesota. Take it away, Kenny.
Unmuted again. Hi, thanks. I assume everybody can hear me and see me. Hello, my name's Kenny. I'm a climatologist with the DNR, and I've got a lot of different kind of focuses here, but one of the things I do is help people understand what's going on with our climate, how it's changing, how it's not. I also have training in meteorology. I've done forecasting. I still actually do some forecasting in a different capacity. And so sometimes for agricultural sectors, we'll give more like weather updates that include some of that other climate information. And that's kind of what we're going to do tonight. I can't see what anyone has put in the chat. I don't have access to that, but
I do,
yeah.
if you want some. We've got only two.
Okay,
We've got Milwaukee, Wisconsin, and then one person said, not going anywhere, but the forest in their backyard to ski when the temps get above 0.
Okay, very good. The Milwaukee, Wisconsin traveler, yikes. One of the big concerns, I think that this storm is adequately hyped, but it might confuse people or throw them off because it's going to snow on Wednesday and Wednesday nights, or tomorrow and tomorrow night in Minnesota. And that's going to be, like maybe we'll get 6 or 8 inches of snow, kind of depends on where you are. And I don't know where everyone on this call is, but it's going to be a pretty gentle snow. When the snow falls, you'll be like, okay, it seems like other times that it snowed. What's the big deal? It will be terrible to drive in, of course, but it'll be done snowing by Thursday morning. And then there will be a little bit of a lull in central and eastern Minnesota, but the winds will start picking up out in western Minnesota early Thursday. And then those strong winds will kind of march across the region and intensify. And the real problem, the snow is going to stick around longer in Wisconsin. It's not going to necessarily be heavier, but the real problem is when those winds arrive, there will be all this fresh snow. And it's not a big deal in the Twin Cities. It'll just make, honestly, Friday and Saturday will be pretty miserable. But anybody traveling between cities, on stretches of rural road where it's really open, or even on the interstates, down through Wisconsin, things could be very difficult, all possibly even impossible on Friday. It's the kind of conditions where, if the plows can't get ahead of things, they'll just end up closing roads. And that's actually true Minnesota, Iowa, Wisconsin, much of Illinois, northern Missouri. It's kind of a whole regional thing, and it's not the usual Red River Valley blizzard. It's more like blizzard-like conditions outside of the urban areas throughout much of the region. So just if you go, be very, very careful. I think the worst of it will be late Thursday into Friday. So even though the snow will have stopped, it's again in those open areas where you won't even know because the winds will be blowing all the snow around and you can't see anything. All right, we could talk more about that later if there's time, but let's talk about what you had me here to talk about, not lecture you about how dangerous it's going to be on the road like bad parents or something. Anyway, I like kind of helping people understand what we do here, and that's just going to be woven through this presentation. The State Climate Office is the official climate authority for the state of Minnesota. So we're part of state government. We are bound to basically collect as much climate data as we can and make that data, those data and climate information, including our analyses, available to Minnesotans. So my job involves a lot of public speaking, a lot of information about what's going on with the climate, how it's changing, maybe things that aren't changing and what the future holds for us. But we do a lot of other things. We run all of the climate observational networks in Minnesota, especially for precipitation, and that really helps us help people in, agriculture and horticulture and hydrology understand how much rain has fallen, how much snow has fallen, how much water has kind of been absorbed by Minnesota over this period of time. And we also keep an archive of all of the major weather events. So, we write up a big story, we put it on something called the Climate Journal, and then we try and save it as part of the climate record. So there will be a narrative of the big tree-breaking snowstorm from the last week that hopefully, lasts for decades and decades, if not longer. Okay. So what we're going to talk about for the most part, when Laura set this up with me originally, the idea was to maybe there had been some anxiety amongst gardeners, and I do a lot of work with master gardeners and master gardener groups, but I know people who are out, planting things are really nervous, especially in the Twin Cities area and South Central and Southwestern Minnesota because of how dry it was in the drought conditions. So there was some anxiety about the drought and how we'll recover from that. And so here's what we're going to do. We will talk about kind of the recent climate conditions and outlook, and then I'm going to fold in later in the presentation some information about the longer term trends that we're seeing. But you're going to see kind of an interesting, or maybe not what you'd expect, focus on the drought up front, and it might sound almost dismissive, and I'm not trying to be dismissive, but anyway, we'll get there. So there's a typo in the first line, which always tells you this is a great way to start a presentation. We're in year 3 of dry conditions. We flipped from exceptionally wet 2019 and then also 2010. So not 201, nobody knows what that is, but 2019 was very wet, and then the 2010s in general were quite wet. So since then, we've had 3 dry years, really, 2020, 2021, and 2022. Now, of those, 2020 was kind of the most normal in other climatic terms, and it was very transitional. We still had some extreme rainfall in Minnesota. 2021, we kind of hit bottom. It was incredibly dry and was also very warm. And 2022 so far has actually been cooler than normal, not during the summertime and not during your growing season, but February through May, that was actually a really cold period, and we lost a lot of ground. And so we're cooler than recent normals and historical averages so far during 2022. I know we're going a long way back, and I tend to remember as much about the weather as is possible, and I'm sure it's damaging to my brain cells to keep all of that useless information in my head. But if you stretch back past the dusty late summer that was frustrating you and try to remember towards the beginning of the growing season, it was actually a really wet spring. we started getting snow and slush pretty consistently in February and then March and April. And it was just a wet, soggy spring. And we, fortunately, we'd been coming out of drought. And so we didn't have the kind of problems with planting that we had in some years in the 2010s when everything was just too wet. But it was a wet spring. We were way above normal for precipitation. And then, of course, we had the extreme dryness in southern Minnesota. Now, this is a hard thing to remember because we just had a big soggy snowstorm come through all of Minnesota and it produced some rain. And with the last couple months have actually been pretty wet, or snowy. But we also have to remember when we say wet or dry or warm or cool, we're usually comparing it to what's normal. And when we look at our winter months, these are our dry months. Winter is, we're almost a monsoon climate with a dry season and a wet season. And our dry season is definitely winter. A typical growing season month in Minnesota gets 3.5, 4, even 4.5 inches of precipitation. And during the winter, an inch of precipitation per month. So the summer months are 3 to 5 times wetter than the winter months. So even though we've been much wetter than normal for the last 2 months, we actually haven't made up that much ground. So we still have these large deficits relative to what we should have. We're still, the Twin Cities area is still, very dry compared to what would be normal. But this early precipitation, this early winter precipitation certainly isn't hurting things, and it might be able to help a little bit. And when we look at the outlooks, and I'm going to, do more than just show you bullet points. I'm going to show you maps and things like that. But the outlooks favor cool conditions in northern Minnesota for basically the rest of winter, but then a warm and maybe slightly wet early growing season. Now, the outlooks you have to take with a grain of salt. We actually, since we don't make the climate seasonal outlooks, we often joke about them. They don't have great track records. Sometimes they're really good and sometimes they're not very good. So we are still in what's called a La Nina pattern. I don't presume that anyone knows or even cares what that means, but there's a climate connection with these other global patterns that are beyond just the changing climate. And the two most common ones out of a whole bunch that you maybe haven't heard of, but the two most common are El Nino and La Nina. El Nino is the name that's given to a kind of unusual warming that's found in the waters off of the Pacific Ocean near the equator and stretching really all the way across the equator back towards, almost into the Indian Ocean, but back towards Indonesia and north of Australia. When that water is unusually warm, it actually changes the circulation of the ocean and the atmosphere, and that ends up changing our weather patterns. And we end up, not always, but frequently we end up kind of warm during our winter time, with a lot of the snowstorms missing us, or maybe we'll be wet and cool at the beginning of winter, but then we transition to a very dry and kind of boring, uneventful winter. That's a very common signal in El Nino patterns. Now we are in La Nina, which is the opposite. That would be when you have unusually cool waters in the Pacific Ocean near the equator, all the way across. And that actually energizes the normal weather pattern. And so you end up, in our part of the country, we end up often with a kind of busier winter. And that might mean more snowstorms, or at least more winter storms in the region, or more changeable weather patterns at a minimum, sometimes more cold intrusions. But there's an asterisk with all of this. The influence of La Nina seems to have changed, and scientists are still trying to figure if that's because of the way the climate is changing, or if it's just because we're learning about other things that affect our climate. It might be both. But this is the third straight year of a La Nina, and the first 2 years, it's in a kind of a long period to have one, but the first 2 years we ended up with kind of normal winters, but really cold periods in February. And we are wondering if we're going to see that. We're off to a pretty fast start here with snowfall. So, all right, now let's look at some stuff. Okay, so I mentioned that it was very wet last decade, and then we've sort of flipped since then. This map shows if you take all of the precipitation that fell in Minnesota, we've got this volunteer network in Minnesota of over 1,000 observers. And now if you've heard of CoCoRaHS, if you add the CoCoRaHS observers, it's another observational network. And by the way, if you're interested in volunteering as a precipitation observer, it's really easy. You just take daily observations using this cylinder. It's like 35 bucks. Contact me afterwards and we can talk. We can get you set up. In any case, from 2010 to 2019, much of southern Minnesota accumulated these huge surpluses of precipitation. It wasn't that it was wet every year or all the time, but we did have a run of wet years basically from 2014 through 2019. And in some cases we were extremely wet. So for example, in the Twin Cities area in 2016, well, in June of 2014, Minnesota had its wettest month of any month ever. So that was on a statewide basis. In 2016, we set an all-time precipitation record for any station in Minnesota, like Waseca, down just hour and a half, 2 hours south of the Twin Cities. And then in the Twin Cities that year, we set our own kind of wettest year on record, and that's a long, long record. Well, that was broken. Both of those records were broken. 2 years later for the Waseca record, and the Twin Cities broke its precipitation record again in 2019. It was just a very wet time. So we have these surpluses of 40 to 50, even 65 inches that are accumulated during this last decade. And that's the equivalent of, depending on where you are, 1.5 to maybe 2 extra years of precipitation. So it's a huge surplus that we developed. And these are just some quick maps. I don't want to dwell too long on them, but this is for essentially the growing season. On the left, each map shows this is for 2019. Very wet conditions, right? We were running 125 to 175% of normal in southern Minnesota. And what that means, most of Minnesota really, what that means is you take your normal precipitation, you add anywhere between 25 and 75% to it. And that's an awful lot to pack in to a growing season. And then on the right, if you remember the percentile ranks, you get them when you were a student to find out how you stood against your classmates. So some of you, I'm sure, were used to finding out that you were 95th percentile or higher. I wasn't usually that lucky. I was much more in the disappointing end of the spectrum. But in any case, you can see that a lot of Minnesota was in the 95th to 99th percentile during the 2019 growing season, meaning it was one of the wettest growing seasons we'd ever experienced. And in some places it was the wettest growing season we'd ever experienced. Now looking 1 year later, same set of maps. Now we're in 2020 for the growing season. And you could see now most of Minnesota is running at least a slight deficit from what's normal. You can see those greens. The color scheme's a little questionable here, but the greens generally indicate slightly below normal to below normal precipitation. And then the corresponding percentile ranking maps show that generally we were below the 50th percentile. So we were, much less favorable ranking for precipitation. And the corners of the states from the Southwest and then again in the Northeast were really quite dry and under the 20th percentile. So we went into really dry conditions in 2020. And then in 2021, it just intensified the growing season. And this is really kind of misleading too, because we were incredibly dry up through about August into mid-August. And then we got bailed out a little bit and got some nice beneficial precipitation. And that's in a little bit of, that's sort of influencing what we're seeing on the maps here. So you're actually seeing the influence of a wet period during an incredibly dry year. but you still see the growing season had a lot of way below normal values in it across Minnesota. And then in 2022, you can see that the Twin Cities area growing season was desperately dry, right? I mean, we were way below normal for precipitation. We were down below the 10th percentile, certainly below the 25th percentile across basically the southwestern fifth or so of Minnesota. So this frustration you were feeling was quite real. I just want to point out this is at the height of the 2021 drought. Look at that. Everything in Minnesota was, getting close to as dry as it had been, or in the bottom 5 percentile. Certainly everything was in the 20 percentile or lower. So that just means out of, if you had to take 100 years, somewhere between 1 and 5 had been drier than those brown areas, and maybe up to 20 had been drier than those red areas, but really very dry conditions. When we look at this thing called the Drought Monitor, this is how we help some of our partners in the federal government sort of assign categories based on not just the climatology, but what's happening with our rivers and lakes and streams and soil moisture and things like that. And the driest conditions in 2021 and the most extreme, or in this case, it's called exceptional drought, was up in northwestern into north central Minnesota, that stripe. That's a very rare level of drought that we actually had never observed in Minnesota since 2000 when this system was devised. So it was the first time we'd ever used that category of drought. It was pretty bad. It generally corresponds to conditions you'd only expect every 40, 50, 60 years. So really bad there. And in the other red areas, it would be more like conditions you would expect on average every 20 years. So still pretty rare. That would be 5th percentile type of stuff. Twin Cities area and most of southern Minnesota was more orange. And there it's just, we had drought conditions. It was bad, but it wasn't really unusual. It didn't stand out historically. And in the 2022 drought on the right, I've got Minnehaha Creek, totally dried up. This is from the end of September. And you can see that the worst of the drought, that stripe of red, the extreme level drought, again, basically something you'd expect maybe every 20 years on average in a given area, assuming kind of normal behavior of the climate. That was really centered over the Twin Cities metro area and into southwestern Minnesota. So the frustration you experienced was real. But one of the things I want to keep in mind is that we're actually coming off the wettest period in history in the 2010s. And the dominant trend, which we'll get at later, has really been for more wet conditions and less drought. And this is hard to square with your experiences sometimes, because drought has this kind of never-ending feeling to it. You're just waiting for water, and so many of the days are just the same kind of rainless days. But really, if anything, drought has become less common in Minnesota over the last several decades. And what's even harder about this is that when we look into the future, we see signs that drought might actually become more severe than we've ever seen, because we think we have very good evidence that our summers are going to be getting much hotter at some point. So, and when that happens, you evaporate more water. So this is all to say, we have had nasty drought. We are still in a pretty significant drought condition, especially in southern Minnesota. Even with all of this recent precipitation, you're still going to see lots of oranges and maybe even some reds on the maps through the winter. But it's not something that really represents a trend. There's no indication that this kind of thing has been getting more common or worse in Minnesota. So we can, there's, in my line of work, there's not a lot of comfort I can offer people, but so far our experience with drought is one area where I can say, yeah, actually it's not something, that's been getting worse in Minnesota in terms of the climate. That said, it's been tough. It was a tough drought. Drought's part of our climate, and I'm glad we have some tools to measure it. And out in southwestern Minnesota, which, soil types are a little different, but this is the kind of thing we would see here in the Twin Cities too, and I'm not sure where other viewers are, but this was pretty common in the dry areas of Minnesota in 2022 and statewide in 2021. The graph on the left just shows how much water was in the soil, the available soil water. There's a little black line that you can see that is that represents kind of the historical averages. And 2022 is the yellow trace, and you can just see that as we go through the year, especially we got into mid-late summer, the soil moisture really crashed relative to what was normal. We had very little water in the soil by the time we got to early October, just under 2 inches. So that's very low. Yeah, so very low soil moisture. And the graph on the right just kind of shows the same thing, but broken into different parts of the soil profile. And you think of where plants get water from. It's not just obviously, it's not just the topsoil, but it might vary in your garden. You might not have 5-6 feet of soil, but certainly farms and many of our forests do. So, and at Lamberton, you can see again in 2022 just this sort of crash of the soil profile moisture. So there really wasn't much by the time we got into the middle and late part of summer and into fall. We ran pretty large deficits. And again, no surprise, we had those same deficits in 2021. And 2020 was kind of transitional because we were coming off of this really wet time. And just to further your sense that it was a really dry episode, here's a tool that we have, and we don't need to spend much time talking about it, but we select all of those counties in purple. This is kind of that really dry area that we just looked at, and then just see how much precipitation we had between June and October when the dry conditions really started. And then the graph is actually showing you every year over that area, going back to 1895, what the June through October precipitation was. And the purple line that I've drawn is just the kind of average, what would be sort of normal based on the climate from 1991 through 2020. And you do see in 2022, the June through October precipitation is the lowest we have on record going back to 1895 in that region. So the kind of late growing season precipitation, mid to late growing season precipitation was significantly low. It's just when you think about what drought really is, drought's usually more than just a few months. It's often, multiple years. And when we look at our multiple year precipitation deficits, we're not really in historical territory or historic territory the way that we are with this June through October period. So that's just to kind of, again, to validate that, yes, it's been an incredibly dry, it was a very dry growing season, especially the latter part of it. Now, if we go back just to the last decade in 2018, and not 1017, but 2017, those two graphs, you see we were mostly above normal. Soil moisture was abundant. We had a lot of water, and in many cases too much water. And this is when in my job I started going to all these symposiums that had never existed before, where you talk about, what are we going to do with all of this water? Where are we going to put it? Or how can we send it to some downstream community that we don't like? That's not what people really could do. But people were concerned there was too much water and it was hard to manage. And this has been kind of the dominant story, not just in the 2010s, but the last couple decades, we've been accumulating more and more water by and large. There's 2016 on the left and 2015 on the right. So now what you see is a 4-year run where we've got generally above, and in some cases way above normal soil moisture. We can keep going back. There's 2014, and you can see beginning in June, that's where we just hit the jackpot. It started getting way too much precipitation. But before that, it's on the left of the left graph. And then for most of the graph on the right, we're actually below normal. And this gets at the dry period that began in 2011 and really really took off in 2012. So we did start the decade, the 2010s, on a fairly dry note, at least once we got into 2011. and we had some nasty drought, but really the dominant signal in the 2010s was the wet conditions that led us to those giant surpluses equal to 1 to 2 years of precipitation, as I showed you in that map that kind of kicked this off. When we look ahead, right, so where we are now is we just got this big snowstorm that dropped a lot of precipitation, and the last 2 months have been pretty wet in Minnesota. We're going to finish December above normal precipitation for sure. But yet we still have these large deficits, especially in the southern part of Minnesota. Well, looking ahead, it's not a really strong signal. The Climate Prediction Center, because of that La Nina forecast, thinks that northern Minnesota, as we go January through March, this would also hold into April, has a decent chance of being cooler than normal and wetter than normal. Not a high chance. I mean, these are actually fairly slight probability differences. You see that white area on both of these maps indicates where, based on the available data, the forecasters can't determine if it's going to be wet or dry. They don't see anything skewing the probabilities one way or the other, so they call it equal chances. You have equal chances of being wet or dry or warm or cool. So it's not necessarily really helpful, and that's actually the story for most of Minnesota for kind of the rest of winter, January through March. That doesn't mean that we won't be very cold or very wet or even very warm or very dry. It just means that there's no signature right now telling us that that's where we're going. And yeah, the early growing season is even less helpful. And this is one of the frustrations with a lot of the work we do, especially in the sectors where people like growing things and they really want to know what the hydroclimate is going to be doing. And it's a tough thing to forecast the behavior of seasons this far out, especially when in summertime you could get a 3-inch rainfall that completely changes whether a month is above or below normal for precipitation, and maybe even affects the whole season. And it's certainly a bigger rainfall or a couple medium big rainfalls can change that too. So you're really sensitive to a small number of events shaping your hydroclimate. And again, for the temperatures on the left there, it's just saying we could be very warm. We don't know. We could also be very cool. There isn't really a smoking gun telling us one way or the other that this is what's going to happen. Those were relatively recently made maps too. I think those outlooks came out in mid-December. So to consider as you think about growing conditions, in southern and central Minnesota, we're still way behind for precipitation. We have been wetter than normal statewide over the last couple months. But if we really want to come out of those deficits, we need abundant precipitation. And one of the things that's interesting is winter precipitation is actually not generally that utilizable by the soil because there's so much runoff and because of frozen ground. So even if you get a lot of precipitation in the winter, the frozen ground often prevents the soil from absorbing that, and it just ends up going into the rivers and streams. And there's been studies that show, only 5 to 50% of wintertime precip is actually utilized by the soil. But when the soil does utilize precipitation that falls during the winter, it's usually because there hasn't been much frost yet, or the frost isn't particularly deep, or it's not particularly rigid. And that's actually the condition most of Minnesota finds itself in, even with these very low temperatures. We have snow all over the ground, and snow is a fantastic insulator. And I don't know about you, but I was actually digging up parts of our lawn right before the last storm, and it was still soft. I was still actually able to move dirt with a shovel in my foot. And so that offers some benefits. It means that some of the moisture that's on the ground now is probably getting in. And because there's snow on the ground right now, even though we've got very cold air outside, the frost levels are not going to accelerate deeper into the soil because essentially the snow is providing a barrier from the air to the ground, and it's really just going to keep the soil temperatures right around, slightly above or right around freezing. So that's actually pretty good conditions for maybe absorbing more than the typical amount of moisture in the winter, but still we're not going to absorb it all. So we have shallow ice and frost. We obviously have had abundant precipitation, and because it's winter, we're not evaporating very much of that. And then you have this sort of conundrum, can we get enough precipitation to come out of the drought without getting too much? Because the way we tend to get precipitation in the winter is through snow. You get a big deposition of a big snowpack, and then in the spring it melts, and if you have a lot of it, you get some flooding. And if you have way too much, you get major flooding, and then you have additional runoff, and you're not doing anyone any favors. And usually in those conditions, we have delayed planting across all sectors. So that's one of the problems with winter being a dry season, and trying to kind of catch up in drought during the winter might put you in a bad situation for the beginning part of the growing season. And so, honestly, probably we should just be patient. Not that we have any control over this anyway, but we'd want to, what you really want is slightly above normal precipitation, probably for the rest of winter, and then a slightly above normal precipitation for maybe April and May, but have it come as extended dry periods that are punctuated by soaking rains, maybe every week. So you've got time for the ground to dry out, then you give it more. You got time to absorb sunlight, and then you give it more. And you end up above normal for precipitation, but not because it was wet all the time. That would be ideal. And if we could do that, we would probably start the growing season in very good condition with, kind of minimal drought categories and a lot of reduction from where we started. We certainly wouldn't have any red in the Twin Cities area if we had, 5 straight months, 6 straight months of above normal, slightly to significantly above normal precipitation. We just want to try and do this without having floods. Okay, so that's a part on the drought, and with the remaining time, I wanted to talk about the kind of larger climate trends and projections and what we want to think about when we talk about our larger climate trends. So first, Minnesota is different from other parts of the US and other parts of the world. We're in the middle of a continent, and so we're literally continental, meaning that when the wind blows from any direction, it's mostly coming from more land, which means it's generally pretty dry. Our one exception is a southerly wind tends to bring us air from the Gulf of Mexico, and that's our main source for humidity and moisture. But sitting in the middle of the continent, halfway between the equator and the North Pole, equal distance from the Rocky Mountains to the Atlantic Ocean and from the Arctic tundra to the Atlantic Ocean, that really exposes us to pretty extreme climate conditions, right? If the winds come from the north, we get northern Canada. If the winds come from the south, we get Louisiana. If the winds come from the west, we get the arid Rocky Mountains. And so we have a very changeable and extreme climate. And you can't say that necessarily about other, you wouldn't describe California's winters the way you would describe ours or their summers necessarily. So even though on paper parts of our climate might look similar to other parts of the world, we have a different story, a different way that we got here. And this matters because as the global climate has begun changing over the last several decades especially, we've seen different symptoms of it manifest in different parts of the country and different parts of the world. Right? I mean, our climate's different from Florida's and California's and from India's. So it really shouldn't surprise us that as global temperatures have increased and that's sort of changed some of the weather patterns around the world, it shouldn't surprise us that the things we see here in Minnesota are also different from those places. Sure, there are some similarities and some overlap, but there are plenty of differences too. So that's one thing. Geography matters here. The other thing that's, I think, intuitive, but also important to bear in mind is that, yes, our climate is changing and we know why, and I'm not even going to bother going into the scientific explanation of why is the climate changing right now. It's a fact, but we also have to acknowledge another fact, which is that our climate, if you were to describe it, 100 years ago or now, it would still have one thing in common, and it's these huge swings, not just going from winter to summer. That's always going to be there, but going from one winter to the next. We, we get these ups and downs. Maybe it's in 2-year, 3-year blocks, but from year to year, we expect a lot of differences in the behavior of our seasons. So even though our summers are generally, short but warm and humid with thunderstorms, we know that some summers are really long and hot and don't have a lot of rain or thunderstorms, and some summers seem a bit cooler and maybe more humid and have a ton of thunderstorms. And we could do the same thing with winter. So we have these ups and these downs, whether you're talking about temperatures or whether you're talking about precipitation, that are essentially native to our climate. And they have always been there since we came out of the ice age. And until our climate undergoes some similar kind of geological, geophysical, or astronomical shift, we are going to always have those kinds of variations. So we have an ongoing change. Our climate is getting warmer. Our hydroclimate is being intensified. We're getting more precipitation on average, but there are ups and downs along the way. So climate trends, this is that sort of persistent ongoing change in the way that one climate variable or another is behaving. Those trends actually coexist in total peace and harmony with these variations. People argue about, this is why you hear silly comments when people are arguing about if the climate is changing, because they confuse these trends and these variations. They essentially confuse short-term climate or even weather with long-term climate. You can have both. So when we get really cold for the next several days, it doesn't disprove any of the things that I'm going to show you about how our winters have changed. And similarly, if we have a really warm day sometime next year, that doesn't prove that we're getting warmer. You have variations that have always been part of the climate, and then you have these ongoing trends where we've got the change in the behavior of certain aspects of our climate. So here's what we've observed in Minnesota in general, and then I'll go into more detail with some evidence here. We've had warmer and wetter conditions on average. You got to remember, you've got your wet years and your dry years, but on average, we've had more warm years than we used to have, compared to some kind of normal baseline. And we've had more wet years than we used to have. And what we now think of as wet is a little bit wetter than it used to be. And what we also think of as dry is a little bit wetter than it used to be. We began observing a major shift. Depending on how you look at it, you could find evidence that it began right around 1970, or you can find evidence that it began sometime in the 1980s. But it's several decades deep now, where we have, not every single year because of those ups and downs, but we've been getting warmer and wetter on average. And this is something we've observed, and it's also projected to just keep on going. So we're going to keep, on average, getting warmer and wetter. So I can't tell you what next year is going to be like or the year after that, but I'm very confident that the 2040s are going to be warmer than the 2020s. I'm very confident that the records that we broke for precipitation in the 2010s will be broken again before I retire in the next, I don't know, when am I retiring? 20 years? I don't know. Anyway, so we have what we've observed and what we've projected to happen as our climate moves into the future. We've experienced shorter, generally warmer winters with more snowfall, but less snow cover. Those things are all actually related. Basically, think that our winters have been warming, but that wetness that I described with more precipitation has also spilled into winter. There's just more water around because the globe is warmer, so there's more ocean water evaporated into the air. So we're occasionally, not every year, but occasionally we're getting higher or historically high snowfall seasons or historically large snowstorms. you know, can't prove that last week's storm was because the climate is changing, but I can say that those kinds of storms appear to be getting more common, these big, wet, heavy snow delivering winter storms. But that's also as our winters are warming, so we're having more thaw conditions during winter. So you can also assume that the growing season is sort of expanding. The frost season is essentially contracting, and then there's this other thing where during that frozen season, we're seeing a proliferation of days where you actually have thaw conditions inside of winter. And those are also at historical high marks. We've had a rapid loss in cold extremes, and that confuses the heck out of everybody because it still gets deadly cold. It's just not as cold as it used to be. And I don't know, this is something where even kind of old timers who don't necessarily accept climate science will often nod along because that's their experience. Of course, it used to get much colder than it gets now. And what we now think of as cold used to be pretty normal. And what we used to think of as really cold doesn't actually happen very much, if at all, anymore. In our summers, we have yet to get really hot. We've had fewer cool nights. Our cool nights have given way to more mild nights, and our mild nights sometimes have given way to warm nights. But we haven't had yet an increase in the extremes of summertime heat, or the number of days above 90 or 95, or the highest temperature of summer. None of that is going up. But our summers are still getting warmer, mostly because the nights are getting warmer, and mostly because those cool nights are getting warmer. And this is the thing, it's the kind of coolest times of year and the coolest nights. That's what's warming the most throughout our region, and not just here in Minnesota. We've also seen bigger and more frequent rainfall events, especially the big ones. So the big ones, it's not every year and it's not everywhere, but they tend to get larger. They tend to come a little heavier than they used to. And those heavy events are a bit more frequent than they used to be. It's not necessarily a night and day difference, but it's something when you look at the statistics, it definitely stands out. You can see big differences over the last 30 to 50 years, and especially over the whole historical record. The heat waves have not gotten worse yet, but all the projections indicate that they will sometime in the next couple to a few decades. We don't know exactly when they'll begin. We definitely are not on our way yet, but that doesn't mean that we're not susceptible, and I'm going to talk about that in a bit. So here's some changes in what we call the climate normals. Series of maps here. And these are just 30-year normals or averages of precipitation across all the different parts of the United States. And then the color scheme and the scale is just in comparison to what was the average for the entire 20th century. So if you see browns, that means it's a dry 30-year period in that location. If you see those kind of green, blue, whatever that color is called, those would be wet periods in those locations compared to the 20th century. And we had really nasty drought, a very long drought here, the Dust Bowl. Those of you who had to read Grapes of Wrath, that was real. Those drought conditions were horrible in the 1920s and especially 1930s. And that definitely affects the climatology. And what you see in our region, we're in the top middle part of that map, if you can find Minnesota there, is you see that we recovered from the drought after that 1950 or 1960 period, and then just kind of went into sort of normal precipitation for about 3 of these climate periods, from 1941 through the 1961 to 90 period. And then the next 3 just got sequentially wetter, and in the last current normal period that we're on the lower right there, we're in the wettest period we've ever observed, not just in Minnesota, but especially in our region, going from the Red River Valley down into southwestern and southern Wisconsin, across into Michigan. And you just see basically east of the Rocky Mountains, the US has gotten wet, really wet. And then west of the Rocky Mountains in the arid regions that don't have much access to moisture, they've gotten drier. And this is kind of the story of how the climate responds to these global changes. Is the wet areas tend to get wetter, or at least have more precipitation, and the dry areas tend to aridify, and you see deserts actually expanding. On the left is Minnesota's annual precipitation with through 1969, there was really no long-term trend. But then since 1970, we've been on average, this is just a, kind of average location in Minnesota, we've been getting wetter. You see that trend line, and you see the little value saying we've 44 hundredths of an inch wetter per decade for annual precipitation on average, meaning a typical place in Minnesota has gained 2 to 2.5 inches of precipitation since 1970. But those dots show you the actual years, so you can see the wet years and the dry years that we've had on that sort of escalator ride to wetter conditions. On the right is a more confusing graph, but we're taking all of the stations, we've got 38 of them that go back at least 100 years, and we're just looking at what the average heaviest precipitation event was around those stations each year. And you can see it's not every year that these values are getting higher and higher, but there is a trend over time. Your eyes will guide you to that. And especially look at the big kind of inflation on the right side of that graph where you've got 5 years that are just way above all the others. We've started having years that are producing daily precipitation values that are just much higher than what we were accustomed to historically. And, in the worst cases where you get the truly massive rainfall events, you have a before and an after like this in Duluth from 2012. And when we look at the models that tell us where we're going with all of this, don't take the details too seriously. On the left is projected changes in heavy precipitation, and on the right is projected changes in average precipitation, both of them kind of centered on the middle of this century, where we're going by the time we get to 2060 or so. And they both indicate more is coming. We don't know exactly how much, but a safe bet would be that precipitation will probably on average increase by the middle of this century by about as much as it already has in the last 50 years or so. So we've come up to 2.5 inches. This indicates we're going to go up by an average of another 2 to 2.5 inches. And heavy precipitation is just going to keep ticking upwards with it. It doesn't mean that every place is going to get inundated and wiped off and have catastrophic flooding every year, but it does mean that these wet conditions are becoming more common. And there's nuance here too, because here's the same set of maps, but for temperature. And so I want you to hold in your mind what we just learned about precipitation. It has been and is expected to become more abundant in Minnesota. Now that means we're just going to keep probably on average measuring more precipitation, but it doesn't necessarily mean we will be wetter, right? Because wetness is a function of not just how much precipitation falls, but how high the temperatures are, because the temperatures tell you how much water you're going to lose to evaporation. And we can see that we have gotten much warmer. And I'm not going to walk you through it sequentially, but the last couple decades, we went into insanely warm territory, pardon me. And, now much of the interior United States is as warm as it's ever been, as warm as we've ever measured in any case. And if we look at how this plays out in Minnesota specifically, these maps are starting to get kind of ugly for me, but I've looked at them so many times, but maybe you haven't seen them yet. They show how different how different parts of the state have been warming since 1895, when our record begins, at different times of the year. So in general, northern Minnesota warms faster than southern Minnesota. So the warming rates and the warming trends in northern Minnesota are just faster than southern Minnesota, but the whole state is warming at an average of right around 3 degrees. So we've gotten about 3 degrees warmer on average across Minnesota since 1895. That means you pluck a typical day out and you take enough of them, and you compare them with a sample from the beginning of the 20th century, and you're probably going to have an average of about 3 degrees warmer now. That's on an annual average basis. In the middle, we have our winter nights. That's the average low temperature, the lowest temperature of each night during the winter, which goes from December through February. And then you accumulate all of those changes over that entire period. And this is where we have most of our warming. Minnesota's winter nights average, 5 to 7 degrees warmer than they used to be just, 100 or so years ago. That is a massive change. I mean, you know, you hear, oh, well, what's 1 degree Celsius or what's 1.8 degrees Fahrenheit? But this is, you know, really warm. So conditions that used to be, you know, thought of as very warm in, say, International Falls are now kind of normal during the winter time. And, you know, that because if you warm a winter night by 7.3 degrees, I mean, you're really kind of jumping into a different climatic condition altogether. And then on the right, we have the summertime days. What are the high temperature trends since 1895 in our summertime daily temperatures, the high temperatures? And we see it's much more subtle, kind of modest warming in central Minnesota and slightly more warming in northern Minnesota, and a negative trend, meaning typical summertime day is cooler now than it was at the beginning of the 20th century in southern Minnesota. It's not a really significant trend, but it is a small trend in any case. And it's certainly, you know, whether that number is the right number or not kind of depends on how you look at it, but it's nothing like what we're seeing with winter nights. Our winters are warming much faster than our summers, and our winter nights are warming fastest of all, and our summer days are warming most slowly right now. Typical January in International Falls is now almost 10 degrees warmer than it was just 60, 70 years ago. So that's a big increase. And so this shouldn't surprise us that this is going out to one of our better stations in western Minnesota. The first freezing day of fall, you see all the ups and downs. So it's not like every year is like this, but it's just the trend. Think of a trend as a predominant tendency. And we're having this predominant tendency to have to have fewer frosts, to have them come later in the fall, and have the last one of spring come earlier. And so really we're losing, you know, 1 to 2 weeks of frost over season and gaining 1 to 2 weeks of growing season in much of Minnesota. This isn't just true for Milan, but it's also true across the state. And so we're getting all this warming, but we're not having a loss, or we're not having a gain of hot weather frequencies yet. So same station out in western Minnesota. And by the way, this is one of the hottest parts of the state on those hot summer days. They're much more likely to reach 100 degrees than, say, the Twin Cities. It's out just east of the Minnesota River off of Highway 7. It's just part of the state that gets hot pretty naturally. And this graph shows the highest temperatures of the year, each year going back to the 1890s. And I should have 2022 on this, but it also doesn't stand out. 2021 was a very hot year, and you can see it on the far right. I'm kind of inside that box accidentally, but it doesn't really stand out in terms of the number of hot days or the hottest days of summer. And there's nothing indicating an ongoing trend towards more of these really high temperature readings. All the old records from the 1930s still stand in most of Minnesota, and there's nothing indicating we've been challenging that. However, when we look at the projections, so we have ample evidence that we're getting warmer, and we have also ample evidence that our summertime heat is not yet getting worse or more extreme, at least in terms of temperatures. But the models unanimously show that that much hotter weather is on the way. And there's a little bit of nuance here, but this map shows, this is actually very, I guess you would call it a very optimistic climate model scenario. You know, everybody kind of figures out their carbon emissions and starts curbing things in relatively short order, and we were able to get both emissions and global temperatures under control. But even in that rosy scenario, by the middle of this century, a typical place in Minnesota would experience 2, maybe 3 times more 90-degree days than what is currently normal during the summertime. So, so we've been protected so far because for a lot of different reasons, we haven't had those really hot days yet, but there's good evidence that they're coming. We don't know exactly when that increase towards this condition is going to begin, but probably in the next few decades, if not, you know, even sooner. And then we have to also expect surprises. So the highest temperatures on record in Portland, Oregon actually look an awful lot like what we would see in much of western Minnesota. Not necessarily the Twin Cities, you'd have to remove a few degrees from these dots for it to be like the Twin Cities, or certainly a town in northern Minnesota. But this is kind of what western Minnesota's high temperature records would look like. And what's interesting, this goes right up through 2020. And if you look at the behavior of the red dots, you don't have anything indicating that high temperatures in Portland, Oregon, highest temperatures on record, are getting higher, that we're breaking these all-time records all the time. And that was true right through 2020. When we add 2021, however, we learned a kind of nasty climatological lesson that year. They added five entrants to their top 50th highest temperatures on record. And if you just look at those darker dots on the far right that are aligned vertically there, they actually proceeded in that order. So day one, it was 102. Day two, it was 103. Day three, it was 108. Day four, 112. Now they had just broken the record twice. All-time record in Portland, Oregon was broken 2 days in a row. And on the third day, they hit 116 degrees. They went from never having been higher than 107 to all of a sudden having done it 3 times with now a new record high temperature that's 9 degrees warmer than where it had been just 4 days earlier. And if it can happen there, right, we're seeing these kinds of things. We saw it in England this summer. We're seeing it in different parts of the United States. It hasn't happened everywhere yet, but if it can happen anywhere, it can happen anywhere else too. And if it can happen in Portland, there's nothing to tell us here in the Twin Cities that it couldn't happen. And the one thing we also have to keep in mind is maybe we won't hit 115 degrees. Maybe we won't do that. Maybe instead our new influx of hot weather days is going to come as extreme humidity events. It's one thing that we have seen an increase in. It's gradual and it's not yet significant, but if we give it a few more years, it might be a significant trend. If we keep seeing this, the muggiest day of the year is becoming a bit muggier. That's basically what this graph shows. If you take the highest dew point temperature that's measured at 6 p.m. or 7 p.m. Any summer day, the highest dew point temperature, there's this long-term, very gradual increase, but it tells us that and we have also seen an uptick, even though like our highest temperatures aren't getting any higher, even though our heat waves aren't getting any longer, there have been more of these kind of extreme humidity heat events. And so when we talk about heat coming in our future, it's not necessarily going to come like this as, extraordinarily hot days with high temperatures that are way above anything we've ever observed. Maybe it'll come as a day where the temperature stays in the 90s, but the dew points are in the 80s. And it's those days that are becoming slightly more common in Minnesota. And so that would also shape kind of the future of, stress to plants and stress to the water systems. So recapping everything we've talked about, we're in a drought. There've been dry conditions, but we've got some hope with the recent precipitation over the last couple months. We need more. The outlooks do not favor either a big improvement or degradation. So really, if we come out of the drought well this spring, it's going to be because we got lucky relative to what the forecasts show. Now, the third point is more about what I just talked about, these ongoing trends over the last several decades towards wetter and warmer conditions, or at least more precipitation and warmer conditions. We've had shorter and less severe winters. We've had longer growing seasons on average. We still will get knocked around by a very cold winter or very dry years, but we've had more precipitation extremes. And the heat and the drought have not worsened yet, right? And I don't mean the drought, I mean drought conditions. Over the long term, we don't see any real bad behavior of our drought showing that it's outside of the historical ranges. The way we saw with the coldest day of the year at, the cold days at International Falls, the overnight lows during January. So we don't have any trend like that with drought. We've just seen that drought's been either steady or declining in frequency. But as we get to hotter summers in the future, and especially when that extreme heat comes, then we know that during those times, we're going to be evaporating more water. And when those extreme heat events coincide with one of the big downturns in our precipitation, so one of those natural or normally occurring downs, well, then we might get levels of drought that we haven't really had in our lifetimes anyway. And maybe they'll even challenge historical levels of drought. So even though heat and drought are not yet showing signs of getting worse than what was historically normal in Minnesota, there's certainly some likelihood, according to the best scientific information available, that they will get worse or more extreme as we get into the decades ahead. And so that's a lot to keep straight. Thanks, everybody. That's the end of my presentation. If you have questions, you can send me a note at this email address. Emma, I permit you to share my address with anyone who asks for it. And you can also, we answer the phone in our office. You won't even get routed through a phone tree. We just answer the phone like regular people used to. So we're pretty old fashioned that way, and it's kind of fun. And we do get phone calls. So feel free. Anyway, thank you.
Awesome. We do have a couple questions. Do you have a couple minutes?
Yeah, I do. I just looked at the clock and realized that I yapped for much longer than I intended to. So.
That is fine. We'll just get to a couple of
sure.
them. We have a question about soil moisture. Does the DNR track soil moisture levels and temperatures below the surface? And if so, do you track them just below the surface to all the way down below frost depth?
Yeah. So the DNR, so our office actually has a frost monitoring station out on the St. Paul campus, which is out in the Ag Experimental Station. We do frost monitoring all winter here. There are soil temperature probes that we have. We have one of the oldest in the world where we're measuring soil temperatures down to something ridiculous like 30 feet, something like that. So we do monitor that through, and that's just a legacy. We've been monitoring that for over 5 decades now. In terms of statewide monitoring, it's a little bit hodgepodge. The Minnesota Department of Agriculture does, I would say, more soil temperature monitoring, and it's not necessarily easy to get all of that information. Hennepin County Emergency Management does soil temperature and soil moisture monitoring. So if you live in Hennepin County, there's actually a pretty extensive network of soil moisture and soil temperature monitors from a variety of automated weather stations around the county. But that's pretty unique. It's not representative of most counties. And then the agricultural experimental stations. So I showed you that graph of soil moisture from Lamberton and both Lamberton and Waseca's experimental stations associated with the University of Minnesota do soil temperature and soil moisture monitoring. So these are very tough quantities for us to get a handle on, especially the soil moisture. It's almost like a holy grail. Everyone wants it. Nobody will do it. Nobody will, like commit to having equipment on their property that they take care of. And it's just been it's been tough. So, but we do have some, and it's, combined with remote sensing technologies that measure gravitational fluxes and how much water is in the soil. We've actually got usually a pretty good handle on how much water is out there. It's just from a variety of sources, and there isn't really a comprehensive way of looking at it. But that's a good question. I'd say the answers are for in both cases, yes, not enough, and we're trying. Thanks.
Great. Thank you. We will get to one more question. What exactly does last frost date mean? And connected to that is the growing season lengthening in both the spring and fall. And are there any changes between northern Minnesota and the Twin Cities and southern Minnesota in regards to that?
Those are great questions. Yeah. Okay. So the first frost date or the last frost date of spring. So think of it like this. You know, at some point in the spring, you have enough sunlight and you have warm enough soil conditions that you can start getting early plant growth and photosynthesis, right? So this can, but usually when you have frost, and especially like a hard freeze, so temperatures below about 28 degrees especially, but even sometimes if the temperature is just 32, depending on what plant you're talking about, I mean, that can be enough to damage it. So um, generally, when we look at the behavior of a given winter, it's helpful to know, okay, when was the last night that we went below 28 degrees, 30 degrees, 32 degrees, and maybe even 34, and maybe even like 25. There are these kind of different thresholds that you can look at. And that sort of tells you when the last frost or when the last hard freeze likely was in that vicinity. Um, and then you can do, and then, so that means after that, all the nights until you get into late fall or mid fall, all the nights remain above whatever that temperature threshold is, freezing. So there wouldn't be any more ice formation anywhere at that point. So that's sort of the informal beginning of the growing season, even though that's not necessarily, you know, it's not like the day after the last frost, things just start growing all of a sudden, but it's certainly where the process begins. And so, especially in agriculture, people like looking at that as kind of a proxy of when you can start, you know, doing serious field work, or at least planning your serious field work. So that's, and then obviously on the other side of the season, you have the first time after a long summer where the temperatures remained above freezing night and day. Now you get into late September or October, or in some cases even November, and you get that first night where the temperature falls below 32 degrees. That's your first frost. And if it's below 28, it's your first hard freeze. And so we just use that. We use those dates to understand the character of not just the growing season, but also that sort of frozen season. So I hope that answer helps. In terms of the behaviors, you know, the urban area in the Twin Cities, for example, has a lot of warming that has nothing to do with, you know, like the climate changing. It has to do with the urbanization. It's called an urban heat island. All the asphalt and rooftops and streets and whatnot, all the infrastructure, it just makes urban areas, even small cities, it just makes them warmer. Um, so generally, growing seasons are longest in the Twin Cities and in some of the other larger cities, and they're certainly much longer than the surrounding rural areas. And then, you know, conversely, the frozen seasons, the frost and freeze seasons, are shorter in those areas. In terms of north to south trends, um, you know, we generally see kind of the same shapes of everything across the state, but because the winters are warming so much faster in northern Minnesota and the summers are warming faster there too, we have seen some of these changes proceeding faster in northern Minnesota than in southern Minnesota. But the whole state is having a lengthening on average of its growing season and a shortening of its frozen season. But there's always nuance here, and those year-to-year variations can make some of that nuance a little bit confusing to people. So, you know, you still can get a good, long, very deep winter in northern and northeastern Minnesota, even if the average suggests that, you know, the winters aren't as long and deeply cold as they used to be. So I apologize that blabbed so much and lost track of time, but I'm happy to take other questions if anyone else wants to ask them to me, either over email or however you like. But thank you very much.
Thank you so much, Kenny. This was a wonderful presentation. Thank you, everyone, for attending today's webinar. If you enjoyed tonight's class and want to learn more, I'd encourage you to visit our website and join us for our upcoming class in January with Julie Weisenhorn on plant selection in a changing climate. After the webinar, you will also receive a survey, and we would really appreciate it if you complete that and provide your feedback. You'll also receive a link to view a recording of today's webinar. On behalf of the Minnesota State Horticultural Society, thank you for joining us today and have a great night. Thanks, Kenny, again.
Thank you very much. Have a good night, everyone. Be safe in the weather.